I am on page 104 of the exercise book, and this is one of those wonky scans. I'm sorry. Let's read the story. Questions 11 through 14 are based on the information below. A sports equipment company recorded data on 3 of their ball launching machines. The pitcher launches a baseball so users can practice hitting or catching. The volley launches a tennis ball so users can practice hitting. And the goalinator launches soccer balls so users can practice stopping or scoring. Each machine ran for 6 minutes, and the total number of balls launched was recorded each minute. So let me switch over to my notebook and let's take a look at number 11. Consider the following table that gives the data for the pitcher. Which of these is a correct description of the function that models the data? Okay, now looking at my y's, I see that there are no duplicates. So I'm going to guess that this may be linear. It's not quadratic, most likely, because I don't see duplicates. And I can't be sure, though. So I'm going to have to check to see which one it is. And I think I'm going to try something here. Let me see if I can crop out. I don't dare do that because I'll have it in such a mess. All right, so let's take a look at this particular problem. And I am going to do this. I'm going to cut that problem and move it to the next page. All right, so we're going to have to set up one of those infernal tables where we find the consecutive differences. Now, this could potentially go all the way out to level 4 because that is one of my choices. I don't think it will, but I've been wrong before. So let's do, now there is one nice thing about this problem, and that is that I don't have to do any math per se, not function math, just the subtraction, because they've already done that for me. They've already evaluated the function in order to get the values for x and y. So let me put those in. And I am going to use a header because that helps me keep the table organized. That is more for my sake than yours, but I would encourage you to do that too. All right, so let's put our x's and y's in here. Now remember that x is the number of minutes and that y is the number of balls launched. So 0, 0, there's your y-intercept. This must be consecutive, and it is. So that would be the first thing I would test, is that x has consecutive values. And then this is where we don't have to do the function. They gave us this information already done. So we're just looking at consecutive differences. So let's take this first column and call that consecutive difference number 1. So I have 4 minus 0 is 4. 8 minus 4 is 4. Now don't get all happy and stop right there, because that still could go a different way. But it's looking pretty good for linear. And the more of these I do, the more I see that the common difference is appearing at the first level. So what can we say about this function? It is common at the first level, so it's linear. and we can stop. We don't need that whole big old table. So the function for the picture is a linear relationship. I'm going to just take a picture of that. Now, it told me that all of them were tested for 6 minutes. So I think I'm going to be safe to just leave those X values alone. I'm trying to line it up and it's not wanting to do that, but that's okay. So let's look at number 12. Oh no, I've lost number 12. Bear with me a little bit. Here's the valley, or the volley. Okay. So here's this problem. I will enlarge it so you can read it. But I need to take out my math that I've done here, and I also need to take out those Y values because I'm sure they're going to be different. Otherwise, why are we doing it again? So let's take out the Y's and put in the new ones here. All right, the volley looks like this. 0, 1, 8, 27, 28, 36, and 63. And we have the same choices, the same question. So let's start doing some math. Then 8 minus 1 is 7. 27 minus 8 is 19. 28 minus 27 is 1. 36 minus 28 is 8. And 63 minus 36 is 27. Let me check that one, because we all know how Miss Amanda does math. When I was in a classroom every day, my students knew that, and they would learn to let me know that I made a mistake. But when you're on here, it's just you and the screen. So this is not common, so it's not linear, since it's not common at the first degree. So let's try the second degree and see what we get. So this will be consecutive differences at the second degree. 7 minus 1 is 6. 19 minus 7 is 12. 1 minus 19 is negative 18. 8 minus 1 is 7. And 27 minus 8 is 19. So it is not common at the second level. It's not quadratic. Okay, since level 3 is one of my choices, in other words, it's choice C, I need to at least check for that. So this is consecutive difference at the third level, and we get 12 minus 6 is 6. Negative 18 minus 12 is negative 28. 7 minus negative 18 is 25. And then 19 minus 7 is 12. So it's not common at the third level. Okay. One good thing, the columns get shorter each time. So we have negative 28 minus 6. That's going to be negative 34. 25 minus negative 28. I'm not even going to try it. 25 minus 28 negative is positive 53. And then 12 minus 25 is negative 13. So it is not common at the 4th degree. 5th degree is not one of my choices, so I'm not even going to try that one. What I'm going to say is that it's probably not a polynomial function. If you can't get commonality at that level, I would guess that it is not a common, or it's not a polynomial function, because it's just not working out. And I believe I'm going to check that just to be sure, because we know how Miss Amanda does math. Number 12 is E, and while I'm checking it, number 11 is A. So we're good so far. All right. I think I'm going to stop this video, and then we'll pick up on the next page.